Hello everyone, my name is Nikitan Dobaria and here we are discussing basic electrical engineering. Up to now we had completed two chapters. First one was DC circuit and last our previous chapter was AC circuits. In this video lecture we are going to start our next chapter, chapter number 3, and that is transformers. Before we start this chapter transformer, let me introduce with what is transformer. First of all, let's start with what is transformer and how it works. Means what is the working principle of transformer here. To understand basic working principle of transformer, let's understand one thing before over here. Here we have two coils over here in which this first coil that is supplied by alternating voltage over here, as we will provide AC voltage to this first coil. What will happen? AC current will be produced in that first coil, and due to that AC current, alternating magnetic field will be generated in first coil. And as this is the alternating magnetic field, means that is a variable magnetic field. Now, if we put this second coil besides first coil, so what will happen? That variable flux which was produced by this first coil, that will be linked with this second coil. So now we are providing variable flux to this second coil, and as we are providing variable flux to this second coil, according to Faraday's law, EMF will be induced in this second coil as we are providing variable flux, alternating flux. So basically, we had produce or induce EMF in second coil because of magnetic flux of first or primary coil. So this is the method, or we can say working principle behind any transformer. And if we will set the number of turns of this coils as an example with compared to first coil, if number of turns of this second coil will be higher, then induced EMF in this second coil will be higher, and number of turns of this second coil will be less compared to first coil, then induced EMF in this second coil will be less compared to whatever supply is provided to the first winding. So basically here, by setting number of turns of these two coils, or we can say by setting the ratio of second coil to first coil, we can increase or decrease voltage over here in the second coil with compared to this input voltage which is provided in the first coil. So this is the basic structure how any transformer will be designed. So let's start with the what is transformer, what is the definition of transformer. So it is over here. So what is transformer? Transformer is a static device. Means what? Here, when we are producing EMF in this second coil, we are not changing position of first one or second coil. They are in steady state condition. They are not moving. So that's why transformer is a steady state machine, means static device. Now, what is its principle or what it do exactly? Now, it transfer electric power from one circuit to another circuit with change in voltage and current level. As we discussed, when power is transferred from first coil to second coil, we can change the voltage level, simultaneously we can change the current level. Now, second, it does this thing but without change of frequency and without change of power. The power and frequency will not be changed during this process. And third point over here, it accomplish this by electromagnetic induction, or specifically we can say that by mutual induction. What is mutual induction? When we are producing induced EMF, or we are inducing EMF in a coil due to flux of another coil, that is known as a mutual induction. So transformer works based on electromagnetic induction, but if we define specifically, that is mutual induction. So this is the definition of transformer. Now, this is the basic structure of transformer. When we will design a transformer, we will not just put two coils together, Why? If we just put two coils together, it will produce EMF in the second coil. But what will happen now? When flux of this primary coil will link with the secondary coil, major portion of this flux will not be linked with the secondary coil, as well as this flux will have to pass through air, so that will provide large magnetic losses. And because of that, when we are transferring power from primary circuit to secondary circuit, one coil to another circuit via magnetic flux, and as we are getting large magnetic losses and 100% flux is not linking with the secondary coil, that's why there will be large or major losses during this process. So to reduce this magnetic losses or to reduce that flux leakage, here we are going to arrange a core or body, and that body will be designed with highly permeability material, means which is having high permeability. As an example, you can consider iron or steel. So this frame or body of this transformer, what will be the function of this core? So that will provide the flux of primary winding to this secondary winding almost 100%. So there will be approximately null or approximately zero leakage flux over here if we are using core. So that's why we are using core. Now again, this is a basic structure of transformer as we had discussed. When we design transformer, first of all, we will need two coils. First coil where we are going to provide supply, that will be known as a primary coil. Remember this thing, where we are providing supply, that coil is known as a primary coil, and where we are getting output, that is known as a secondary coil. So here this is our primary coil as we are providing supply, and as we are getting output over here, this is our secondary coil. And this square portion, that is the core or body of that transformer. And as we mentioned in our previous slide, this core will provide the flux of this primary winding to this secondary winding. So this is the basic structure of transformer, where this green color dotted line, which is representing the flux line which is flowing or setting up in this body. Now this diagram is representing basic symbol of transformer. Here this is first coil, which is primary coil for us as we are providing supply to this coil. This second coil, which is secondary coil, as we are getting output and we are providing output to another circuit over here. And this vertical lines over here in between these two coils, these vertical lines are representing core. That means if there will be these two vertical lines, that means there will be core in actual transformer. And if there will be no lines which is over here, that means that transformer will be air cooled. That means flux will pass through just air. So this is the symbol of basic transformer, where we had connected source to this primary of transformer, and as well as we had connected load to this secondary of this transformer, and we had also defined basic parameter for this transformer. As an example, here we are providing voltage to primary winding, and that voltage is defined by Vp, primary voltage. Same way as we are getting output voltage or secondary voltage, that is Vs or Es over here across secondary winding, so that will be defined by Vs or Es secondary voltage. Same way here we are getting the primary current in primary winding, so that is primary current Ip, this is secondary current Is. Same way, number of turns of this primary and secondary coil is defined by this Np and Ns term respectively. So this is the symbolic form of any transformer. Now let's discuss the actual construction of transformer. There will be two types of construction of transformer. First one will be the core type and next one will be the shell type. Let's start with the first type, and that is core type. So what is core type? In core type construction, first of all, we consider a core, means this body of this transformer, and as we mentioned in our previous slide, when we design core or body of the transformer, We will choose material with high permeability. Why we are choosing material with high permeability? As what is the function of this core or body? It provides the flux to next winding, and that's why flux is going to be flow through this body or core. And to reduce magnetic losses by magnetic flux, we will use material with high permeability as it will provide less losses, and that's why normally we will prefer steel or iron. And exactly I can say cast steel or cast iron, which is having high permeability. As well as after forming this core or body, we are going to wound two windings, primary and secondary winding, on this vertical section of this square body. Here, this horizontal section of the square body is known as a yoke, and this vertical sections, this one and this one, are known as a limb. So basically in this structure we have two limb over here. This is first vertical section means first limb, and this is second vertical section means second limb. And this primary and secondary, this two winding will be wound on these limbs, means on this vertical section as shown in this diagram. But previously in symbolic form, we had seen that we had wound a one winding on one limb and another winding on another limb. But to reduce magnetic losses or leakage flux again, we can do one more thing over here. What will we do over here? First of all, we will consider one winding over here, and we will wound 50% of one winding on this limb, and another half winding means 50% of same winding on this another limb. Same way, we will take second winding and we will wound 50% of second winding on this first limb and another 50% of that second winding on this second limb. As shown in this diagram, we can observe that there will be two winding, primary and secondary, and which winding having low voltage, that is going to be known as a low voltage winding, and winding which is going to have high voltage, that is going to be known as a high voltage winding. So here we will consider winding as a low voltage winding and high voltage winding. So if you observe this diagram, here we had wound this high voltage winding here in inner side of this portion, inner portion, and same way another half winding, that high voltage winding, that was wound over here. Same way we will consider next winding is low voltage winding. So 50% of that low voltage winding is going to be wound on this limb, and another 50% of this winding is going to be wound on this another limb. Next thing over here, when we will wound this winding on this limb, as we mentioned before, this core is going to be maybe cast iron or cast steel. That means that is going to be some metal. Same way, these wires, normally we design wire by copper material or aluminum material. So whatever we consider that is going to be conductor, same way this body is again conductor. So if we put winding and core together, that can create short circuit. So first of all, we will need to provide insulation between those two. That's why when we will start winding over here, so on this core or on this yoke, we will provide insulation, and after providing insulation, we will start wounding first winding, and after completion of one layer, we will provide another insulation to separate these two windings. As you can consider here, we have a two winding. This first winding which is mentioned by this yellow color, and second winding which is mentioned by this dark color. So there will be a layer of insulation in between these two windings to separate these two windings, so which is mentioned over here. Here first there will be a layer of insulation, next there will be a winding, again there will be a insulation, and after that again there will be a winding over here. So we will provide insulator in between two windings as well as in between winding and core. Let me add one more point over here. When we will design this core or body, we will not design this body as a solid material. Instead of that, we will take plates and we will put these plates together like this way. As an example, if this is one plate, we will put another plate on that. Again, we will put next plate on that, and by that stack, creating stack of these plates, we will form a body. And when we will take these plates to create a body or core, we will use these plates as the laminated plates. Means on these plates, lamination will be applied. So when we will put these two plates together, so current will not be able to pass through two plates, or at least it will reduce the flow of current through this body. And why we are using this laminated plates, or that is known as the laminated core, which is formed by laminated plates to reduce eddy current loss, which is nothing but a magnetic loss. So this is the basic core type structure. Again, let me remind you or define you what is core type structure. Where here, first of all, observe this diagram. When this winding will be wound, and if we observe this structure, so what will be seen over here? This limb section will be inside of this winding. So we will find out the winding outside and limb will be inside. So what is core type transformer? Where winding will surround the limb, means core, that kind of structure is known as a core type structure. This is the symbolic form of core type transformer. Now next one is a shell type transformer. Now, in shell type transformer, there will be three vertical limbs as shown in this figure, and as previously we had one square body. So basically, center portion, that hollow portion, is known as a window. So that was only one window. Here we are going to use three vertical limbs as shown in this diagram. So now basically we have two hollow sections, this yellow color section. So now we are having two windows. This both diagram are same, but this is a just cut section of this upper diagram. Now let's understand this diagram. As we have designed this core over here with this three vertical limb, and now we are going to wound a winding on center limb. So as shown in this diagram, we had wound both winding, primary and secondary, or you can say low voltage and high voltage winding on this same vertical limb. And when we will design or wound this winding, so method of wounding this winding is going to be different when compared to previous one. As you can observe over here, as an example, we will start with low voltage winding. So here in this diagram, you can see observe that this section is representing low voltage winding. So on a particular section, we had wound a low voltage winding. After that, in this next section, we had wound high voltage winding. We had created layer of low voltage winding, layer of high voltage winding. Next, again we had created next layer of low voltage winding, and again we will create next layer of high voltage winding. The same way, first of all, we will create a layer of low voltage winding. Next will be layer of high voltage winding. Next will be layer of low voltage, high voltage, low voltage. So this kind of winding is known as a sandwich type winding. But always remember that when we will create this kind of layers, so first layer and last layer of these winding is going to be layer of low voltage winding always. So this is known as a sandwich type winding, as we are creating winding or winding by creating layers as we design in sandwich. That's why that is known as a sandwich type winding. So this structure is known as a shell type transformer. And material that will be chosen for winding or material that will be chosen for core, that is going to be same as we had discussed in core type transform. Now let's compare the core type and shell type transform over here. Here we will compare this both transform by considering its definition. So what is core type transform? Core type transform where winding is surrounded to limb, and if we consider in shell type transform. So what is shell type transform? If you observe this shell type structure over here, this winding is going to be over here in the center limb, but this two limbs, this first and third, that are the outer limb, that will cover the winding from outside. So when you will observe the transformer, we will find out that winding is inside and this limb is outside. So now limb has surrounded the winding. So that is known as the shell type transformer. Okay, so basically here in shell type transformer, on center limb we had wound a winding, and that winding is covered by this outer limbs. So basically we had covered the central winding by this outer limb, and that's why that is known as a shell type transformer. Now second is lamination shape. That means when we will design the core or yoke or body as in core type transformer, we are going to form core in shape of square. So when we need to design a square, as I mentioned, we will not design core directly to the shape of solid body or with direct square shape. Instead of that, what we will do? We will design that core in different structure, different shapes. As an example, you can design four I type section. As an example, you can design four vertical sections. So this will be our first section. Next we can add next section, same way we can add third, and same way we can add fourth section. So by combining this four section, we can design a one square section as shown in this structure over here. So this is going to be first, second, third, and that is going to be fourth section. So basically we will have four I section. By combining that I section, we can design a one square section over here. Or you can use two L section. As an example, you can consider this one L section. You can consider this another L section, and by putting this two L section, again you can form a square section. Same way, when you design shell type transformer, again we can use different types of small section, and by combining this section we can design a shell type core. So for that we can use E section, I section, or L section. Now next, copper requirement means to form a winding, how much copper will be required. So in core type transformer, more copper wire will be required with compared to this shell type transformer. Now winding type, as we had discussed, in core type transformer we just wound a winding around this limb in form of just cylinder. Basically we are wounding a winding in form of a cylinder like this way. So that is formed as in shape of cylinder. That's why that winding is known as a cylindrical winding. And as we had discussed in shell type transformer, that winding is wound in layers, and that is known as a sandwich type winding. Now, limb in core type transformer there will be two limbs. In shell type transformer there will be three limbs. Now, insulation in core type transformer, insulation will be required more with compared to shell type transformer. Last, flux. As in core type transformer, there is only one path, as this is the only square section. So flux will be same in all section, but what will happen in shell type transformer? In shell type transformer, there are three limbs. From central limb, flux will be generated, and that will be divided into outer limb. So in center limb, like 100% flux will pass through center limb, and that will be divided 50 and 50% in outer limb. So basically, with compared to this two outer limb, in center limb, flux will be double. Now, if we compare again core type and shell type transformer based on windings, So here, as we had discussed, cylindrical type and sandwich type winding. In core type, primary and secondary windings are placed on side limbs, whereas in shell type transformer, both windings are placed on center limb. Now, magnetic circuit, as we had discussed, in core type transformer, there will be only one path, so there will be only one magnetic circuit, whereas in shell type transformer, there will be two paths, so there will be two magnetic circuit. Now, magnetic losses in core type transformer, losses will be higher with compared to shell type transformer. Again, maintenance in core type transformer, maintenance is very easy with compared to shell type transformer. Again, mechanical strength of the transformer. So, in case of core type transformer, it is mechanically little bit weak with compared to shell type transformer. And last point, that is output. So we can say that shell type transformer is little bit efficient, more efficient with compared to core type transformer. In other way or in simple way, output of shell type transformer is going to be less with compared to shell type transformer. So this was the basic comparison between core type and shell type transformer. So thank you for watching this video. Stay tuned with me.